This short video presents the results of my initial work on extending the source code for Scratch to include the capability to interact with a remote robot over a serial link. Scratch is a programming environment created by the MIT Media Lab. It's a very appealing program for young potential programmers, and I wanted to see if I could make it work with real robots. In order to avoid confusion with Scratch itself, I've decided to call any spin-off development here itchbots, for lack of something more imaginative. So I'll start with describing the prototype robot. It's based on a Freescale 9S12C32 microcontroller mounted on a 32-pin dual inline package. This package is known as the Nanocore 12DX and is sold by Technological Arts. The package provides basic clock, reset, and power functionality and offers an RS-232 level shifter for serial communications. The pins in the package export the microcontroller's internal functionality. I've mounted this package onto a circuit board containing a motor driver circuit based on the L293, a power regulation circuit, and mounting poles for motors, batteries, and so far 3 sensors. The sensor suite for this robot is not extensive. It consists of a single sharp IR sensor that can see objects out to about a foot. This robot platform communicates with the Scratch source code through a serial cable and a USB serial port adapter. In future, this serial cable will be replaced by a wireless serial modem. This is the interface to the robot as seen when the Scratch source code is executed with the changes that I've documented thus far. As I've noted in the documentation, I've leveraged what I could from the sensor board watcher and the GoGo board interface. As you can see here, the sensor board watcher will display the values of sensors, buttons, or switches that it is monitoring. In the microcontroller interface code for the robot, I'm reporting the value of the sharp IR sensor using the address normally associated with sensor B. So if I select a COM port and start the sensor board watcher listening, and then start the robot, I should see real-time data from the IR sensor into the position marked sensor B. And there it is. So I'm reporting raw data. If I move some object in front of it, I should see the serial port report a larger value for the IR sensor. And there it is. On the left, I've included a sample program that I will use to demonstrate the functionality for the robot interface. As I noted in the documentation, I've added the 3 new buttons that control a pair of motors. These buttons turn motors off, make motors go forward, and make motors go backwards. This program starts with a control structure that waits on a spacebar press. When this happens, motors 0 and 1 are turned on using new blocks. The program goes into a loop that executes until a certain condition is met. In this case, the condition is that the IR sensor value that's being fed to sensor B exceeds 90. The test for this case makes use of the existing blocks for testing sensor port values. In this case, I keep an eye on sensor B, resistance B. The inner loop, of course, does nothing, as there's no blocks there. So when the IR sensor value exceeds 90, the loop breaks and the program carries forward with stopping both motors. So now I'll run this code and demonstrate the functionality. So here's the robot waiting patiently for commands from Scratch. And as I mentioned earlier, it's waiting specifically for me to press a space bar on the keyboard. I'm going to put an object in front of it, and hopefully it'll stop before it hits that object. That's what the program is intended to do. And here I go with pressing the space bar. And there it goes. I'll run another demo. And there you have it. A robot interface for the Scratch source code.